Hi folks, we're going to take a look at page 392, number 13, one of the challenge questions that I've given. So here what they tell us is that if these two equalities are true, in other words, if log base b of a is equal to c, and log base y of b is also equal to c, they want us to show that log base a of y is equal to, in the book it's given as c to the negative 2, but I'll just rewrite it here as 1 over c squared. Okay, so in other words, we have to use this information given to somehow prove this equality here. Okay, now when I take a look at this, these two givens here, I might be tempted to make these two things equal, since they're both equal to c. The reason why I'm not going to go there, I mean, I'm not saying it might not work, but I don't think that's going to be my first try, because I want the c's to be in my result. Okay, so by equating these two, I kind of get rid of the two c's. So that's why, like I said, I'll come back to that if I have nothing else to show. But for now, I'm not going to go that route. Okay, instead what I'm going to try to do is I'm going to try to manipulate this expression here, okay, using these two givens to see if I can make it equal to 1 over c squared. Okay, so let me start with the left-hand side here, okay, as we often do when we're trying to prove some kind of equality, is we start with one side and we try to show that it's equal to the other side. Okay, so log base a of y. Okay, so what I'm going to try to do is I need to try to find some connections to these two equations. So here I notice that the a is in the base. I'd like to have something that has the a perhaps not in the base but in the input of a logarithm. Okay, so I notice here I don't have any a's in this second one, but I do have an a there. So how can I get this a in the base into this a as an input? Okay, well, this is where I hope you're thinking of the change of base formula. Okay, because that's exactly what the change of base formula is. So what I'm going to do is I'm going to take this expression here and I'm going to change it to the base that's being used in this first equation. So I'm going to change it to base b. Okay, so the first thing I'm going to do is change this to base b. So this is going to be log base b of the original input, y, and in the denominator, log base b of the original base, which is a. Okay, now that's something nice because now I know what log base b of a is equal to. It's equal to c. What I also like is that that c is in the denominator. Okay, which is exactly where I want it, since I know I need to show that the original expression is equal to 1 over c squared. Okay, so it accomplishes, looks like it accomplishes part of what I need to show. Okay, so my next thing is going to be working with this expression here. Now just to make my life a little easier, again, something that's nice to separate things out. I've got this c in the denominator, so I'm going to rewrite this as 1 over c times log base b of y. Okay, these two are equivalent, but it's just kind of getting that 1 over c out of the way so I can now focus in on this next expression. Okay, so let's see what I can do here. So now I notice I've got a similar scenario. I've got a log base b, and here the b, again, is no longer the base, but it's in the input. Okay, so I'm going to do the same thing. I'm going to do a change of base on this expression here. Okay, and of course I'm going to change it to the base that I see in this equation, to log base y. So if I change this expression to base y, well, again, it's log base y of the original input, which is y, over log base y of the original base, which is b. Okay, now a couple of nice things happen here. First of all, log base y of b is equal to c. Okay, but what about log base y of y? Well, remember what this represents, this whole expression. It's the exponent of y that gives you y. So that's just going to be equal to 1. So I'm left with 1 over c times, and here I've got 1 in the numerator, and log base y of b is just equal to c. And there you have it, exactly that thing we wanted to show. Sorry, 1 over c squared, of course, when I multiply that out. Okay, so just to give you a sense of, again, the thinking behind these, and it really is about looking for patterns, similar to that other challenge question that I gave. It's looking for those little connections between what's given and what you're working with. Okay, so number one, I didn't just equate these expressions, okay, because I didn't want to get rid of the c. I needed to work with the c's in order to get the expression that was required. Okay. Number two was realizing that, an expression that I had in my base, I needed outside of my base. I needed as my input to a logarithm. So that's what made me think of using the change of base formula. Okay, and then from there, it's just again to see those patterns